That is okay. Yeah, you are in the majority if you hate fractions, but a lot of people hate it just because it's different and they get confused. So I just want to tell you, don't. They're just so. I like that. I like that a lot. See, Joy, this is a good class. You're gonna enjoy it. I love it. I love it. Okay, so my question of the day, I'm just kind of curious and all that. Are there more inches in a mile or seconds in a day? What do you guys think? And what's your reasoning on that? Joyce says seconds in a day. You guys agree? I will assure you, you are right. Yeah. Oh, wait. Sounds like it. Oh, inches in a mile. I love how you quoted yourself and signed your name. Okay, a lot of people say inches in a mile. Let's think about this. No, seconds in a day. Jen, say it right, Jen. Okay, wait. I gotta get out my magic pad here. So we know there are how many, what do we know about inches and miles? We might not know inches in a mile, but we know inches in feet. Yeah, I think you guys are right. I think you're right. 24 hours is there's six. Yup. Yeah, I agree. I think it is obvious. So we know there are 12 inches in a foot and 5,280 feet in 1 mile. So we've got to take those feet and change those into inches. Ooh, look at that, Joy. Is that sarcasm, Isaiah? So Joy said there are 63,360 inches in a mile. How did you get that, Joy? How'd you get that one, Joy? Oh, yeah. Okay. So, like, mathematically, what did you do with that 12 and with that 5,280? What would we do with those there? Or for anybody, what do you guys think? If I know there's 12 inches in a foot and 5,280 feet in a mile, what am I going to do with those two numbers? Parker. Parker. You silly. Yeah, we're gonna multiply. Yeah, and then we get that 63,360 or whatever she said. I think that's what she said. She by Joy, I mean. Yeah, that's what we would get. So that's how many inches are in a mile. Okay. Ooh, look at that. Joy's thinking. And then she says 86,400 seconds in a day. So there are 60 seconds in a minute. How many minutes are in an hour? Yup, 60 minutes in an hour. And then how many hours in a day? It's all right. 24. Yeah, 24 hours in a day. So we would take 24 hours and we would do what? Probably the same as the other one, right? Because each of those hours stands for 60 minutes, so we would multiply. Oh, it really doesn't have anything. It's just a math topic. It's totally off topic. It's always good to think of getting things in the same units, though. So I think that's why I grabbed it and I put it in there, because it... Oh my gosh, are you serious? Aiden, oh, that would drive me nuts. But it's okay. We got this, Aiden. We will work around it. We will overcome. We got this. But you're absolutely right, all of you that kind of said it. And Joy, thank you for reasoning out all the math and stuff. I will not take credit, I promise. But that was very epic of you, Joy. Good job. There's definitely more seconds in a day. And I think what Parker was saying and with what you guys were saying, it is obvious. Mariam said that because there's more jumps that you have to make in order to get there. Good job, guys. All right, so this is what is due this week. Joy, I do have to adjust your assignments, and I will do that right after this class, but because you already did like the orientation and all that stuff, so you don't need to do it again. But you guys have all Math Excel assignments. You're working on equivalent fractions, and then adding and subtracting, and then multiplying and dividing. So yeah, all fractions all the time. Yay! No, I'm just kidding. Just this week. We got this. All right, let's start with equivalent fractions. Equivalent fractions. Equivalent fractions, they have the same value even though they look different. Okay? So equivalent fractions, they have those same denominators. So remember, every fraction, just to remember our terminology here, the top of our fraction is called the numerator. What's the bottom called? Yeah, really. The Den Bos Medicador. Yeah, that's the new name, Isaiah. No, I'm just kidding. It's the denominator. It's always the numerator over the denominator. And a lot of people say this is probably the easiest part about fractions, just because it just involves multiplying to get them to be the same thing. And remember, whatever you do to the numerator, you always do the denominator. Yes, always simplify, always. Always and forever. Simplify. And that means you divide it down until it's in low terms. Okay, but the main thing is equivalent fractions are fractions that have the same value even though they look different. So 4/8, good, yeah, 4/8 is the same as 1/2. Because if you look at our diagram here, here's half, like if you think of this as like a board, okay? And if you take this board and you split it in half, there's half and half. And there's 4 of those little 8s that fit in that 1/2. And that's okay. Some of you guys are saying it's just simplifying, but that's tricky. Yes, it is. We do. We actually have quite a few, Joy. It's pretty awesome. Multiple jokers. I like it. It's the only way to teach math, right? Is to have fun. So other ways to view it is if you're trying to get similar fractions, we multiply the top and the bottom by that. And this is how you would get same fractions if you ever have to add them. Because remember, you have to add like denominators only. And then if we simplify, that's going back down. So we would divide to go the other way. So it just involves a bunch of multiplying and dividing. Yeah, I'm gonna tell you guys, I like denominators are easier, right? Makes me mad when they're unlike, but we got to deal with it, you know. I will tell you guys, there's a lot of good resources out there if you're having trouble simplifying or anything like that, but we really got to practice doing it without calculator assistance because it makes it so much quicker to do other types of math. And in Algebra 2, right, Desmos does help with that. It's super helpful. However, in Algebra 2, you're going to have expressions that you have to simplify. So you might have something like this that you're going to use different simplifying concepts for. Take it back. Never. We love Desmos. Okay. So, one thing you're going to have to do always is write a fraction in lowest terms. Always. Okay. So, the first thing you're going to do is, if you have to, list the factors of both numbers, or ask yourself, what is the biggest number I can divide both the numerator and the denominator by? Because usually I don't list factors. However, you can do that. What is the biggest number I can divide the numerator and denominator by? And it's got to be both. Okay? Or you can list those factors. Yeah, and a lot of you guys are saying 5. A lot of you are saying that. Technically, 15 is the biggest. However, it's absolutely acceptable to divide by 5. Okay, so let's say we list the factors, which we really don't have to do because it ends in a 5 and it ends in a 0. So we know it divides by 5, right? If your numbers end in a 5 and a 0, you know they divide by 5. So you totally can divide by 5 first. You totally can. But if we listed those factors, so let's list what multiplies to be 15. Let's see. So it'd be 1 and 15. What else? What multiplies to be 15? 3 and 5. Yeah. Anything else? I think that's it. Oh, you guys. So 1 and 15. Sorry, 3 and 5. Those are our factors of 15. What about 30? So 1 and 30. What else? 2 and 15. Yup. 6 and 5. Perfect. Oh, we forgot about 3 and 10. You're so right. Yeah. So when you do this, you could say, oh, look at that, guys. They do both divide by 5 or 3, but the biggest one in common that they both divide by is what number? 15. Yeah, 15 and 15. So the easiest thing is probably just to divide by the biggest number. Divide both the numerator and the denominator by the greatest common factor, which is 15. And you guys already called it. We definitely get 1/2. Yeah, very good. Is it acceptable, guys, to divide by 5? Of course. Sure is. So if we have 15 and 30, and you guys said 5, you totally can divide the top and the bottom by 5 first. Then you get 3 and 6. Then what would I have to divide by? What's in common with 3 and 6 that I could divide both of those by? By 3, yeah, both of those can be divided by 3. So that's 1/2. So it's fine if you divide by the smaller numbers first. Okay? But the process is you list the factors of both numbers, check for common factors, and divide the numerator and denominator by the greatest common factor. Questions on that? Any questions? You're not dumb. No, not at all. And you actually could. It's just we don't want to divide by decimals, right? Yeah. Because that's too much work. Yeah. Any questions on that? If you have no questions, please write no questions. So I know you're with me. Oh, Joy, that's so nice. Yes, you are right. Different way of thinking. Nobody's dumb. We all just have different ways of thinking, right? Alrighty. So take a look at what's on the screen here. We've got a bunch of fractions that we have to simplify. Okay. Bunch of them. So take a second, write them down. And remember, we're asking ourselves, what is the biggest number you can divide both the numerator and the denominator by? And if you can't think of that, then just start thinking. I would look for even numbers first. That's what I would look for. So like this one, they're both even. What can even numbers always be divided by? By 2, yeah. Perfect. Perfect, perfect. All right, so I think Jonah answered the first one. And someone else said it. I think it was Parker. I don't remember who. Said it looks like it divides by 10. Yeah, you guys are right. Anytime they both end in a 0, all we have to do, because whenever there's the same on the top and the same on the bottom, they cancel itself out. So it's 5, 6. And that is exactly the same as dividing by 10. Good job. Yeah, and that's the same as 7. Joy, very smart, looking ahead at other similar ones. This one also has zeros. Good. Nice. Okay, let's look at number 4. What should we divide? Good job, very good. What should we divide number 4 by? What's the biggest number? Isaiah says 9. Jonah says 9. You guys all say 9. Okay, let's do that. So what's 18 divided by 9? 2. And what's 27 divided by 9? 3, yeah. And remember, if you're not very good with multiplication or something, that's okay. That's no problem. All you would do is on a calculator, you would say, okay, 18 divided by 2. Okay, now 27 divided by 2. Oh, that gives me a decimal. Can't do that. Here, let me show you what I mean. So if we bring up our calculator here, I'm going to not use Desmos. What? Just because Desmos does a lot of simplifying for us, and I don't want that right now. There it is. I know I'm betraying Desmos, but here's the calculator. So we could go, okay, 18 divided by, nope, that's times. Look at this. I can't even use a non-Desmos calculator. 18 divided by 2. Well, that works. That's 9. Okay. And then 27 divided by 2. Oh, that's a decimal. Doesn't work. So it can't be 2. Now let's try 3. 18 divided by 3. Okay, that works. We could divide that by 3. 27 divided by 3. Oh, that works. You guys are plowing through it. Very good. So 2/3. Okay, what about number 5? What do we get for number 5? I'm being too slow. Joy says 1/8. Who agrees with Joy? Yay, good job. So what did you guys divide by? By 3, yeah. Yeah, 3 and 8. Okay, you were trying to type that. I got you. I got you, friend. Yes, you're right. 8 times 3 is 24. So that is what we divided by. Good. What about 6? Number 6. That was our even one. You could start by dividing by 2. But Mariam is suggesting 4. Dividing by 4 to give us 2/3. So if you divided by 2 first, you would get 4/6, and then divide by 2 again to get 2/3. Nice job, Joy. We already have 7, and what about 8? What's the biggest number you can divide those by? 6 times 8 is 48. Good. So that means we can't divide that 8 by 6, right? We would divide that by 8. So we get 1/6. Very good. Please let me know if this is confusing. Send me an email and say, Mrs. Dega or Jen, I hate fractions. Can we work together? Yes, absolutely. All right, let's talk adding and subtracting fractions, okay? In order to add and subtract fractions, what do you need? What needs to be true? You need fractions, yup, and a brain. Yeah, Joy, that's kind of, and Jonah, that's kind of what I was getting at. You guys are the best. Yes, yeah, you're going to need a least common multiple in order to get common denominators. Remember, you can only add fractions or subtract fractions that have the same denominators. Okay? So if they already have the same denominators, you just add the numerators or subtract whatever you're trying to do. So 1/5 and 2/5 already have the same denominators. So we're just going to add the numerators only and then keep the same denominator. And then you do have to simplify. Don't forget to simplify if you have to. And that means putting it in the lowest terms. And if you're subtracting fractions, if you already have the same denominators, it's the same thing. You subtract the numerators and copy the common denominator. Okay? So we like equivalent fractions because they go a little bit easier. Does that make sense, friends? Equivalent fractions are the way to be. Yeah. So let's do it. Okay, so we'll try this. So for number 1, we already have the same denominators, so what would my answer be? 5/7 is correct. Very good. You did it. Yes, you did. Very good. Very good. Okay. Yeah, yeah, I'm used to using X as in X and Y. Yep. Yeah, you're right. Yeah, so I'm going to try and use parentheses. We want to switch over to parentheses as multiplication. Yeah, it's a good point. So this next one, yeah, we have 5/7. We add the numerators, keep the same denominator. Looks like Isaiah did the next one, and Parker. We add the numerators, keep the same denominator, but what do we have to do there? What do we have to do there? We have to simplify. Yeah, what can we divide those by? Oh, goodness. Uh-oh, that's not good. Usually that means they're calling about my daughter. 2/3, right? Divide by 2. Yeah. Yeah, we would divide by 2. Oh, we wouldn't get 2/3. That was probably for a different one. Sorry, guys. Yeah, we would get 5/7. Yep, you're right. 5/7 because we add the numerators, keep the same denominator, and you're dividing by 2 because they're both even, right? 10 divided by 2 is 5. 14 divided by 2 is 7. Okay, what about number 3? Same denominators. That's okay. Yeah, we want to try and stay on pace with everybody. We don't want to rocket ahead because not everybody handles fractions the same way, right? Yep, Mariam's saying is we get 4/6. We add the numerators, keep the same denominator, and then simplify. They are both even, so we divide by 2. That's okay, no big deal. And then the last one, we have 3/6 minus 5/6. What do you guys think? And we should probably write it like this. 3/6 minus 5/6. Yeah, this one's an interesting one to figure out there. Oh my goodness. It's okay, guys. We're all right. Yeah, in this case, I think we would just have a... See, sometimes Jen has to check her reasoning here. Yeah, no, we would just be cool with negative. Yeah, we would just leave it as a negative. The only time, because 5/6 is a smaller fraction than 3/6. Yeah, so that would be, no, that isn't. What am I saying, Jen? No, we would just go with the negative answer. That would be okay. So we would go 3 minus 5 gives us that -2, and then we would divide to get that -1/3. There are times where you're gonna have to borrow and make a mixed number, but this is not that case. Nice job, all of yous guys. Yeah, we would just go with the negative. And remember your rules, right? We're subtracting 3 minus 5. We keep, change, flip. So it's really 3 plus -5. We have $3. We owe 5. That means we still owe $2. So there's a lot there. Any questions on that? We kind of went through that a little bit quickly because we have a lot of fraction stuff to talk about. Yeah, well, we're going to keep going. And I'm going to find out when we have that borrowing thing. I believe it's with an answer, but I will double check on that. I will. I'll either send out an email or a video because I'm not sure. Yeah, let's get through this first. We'll get through this. Don't you guys worry. Okay, so now when we have adding, we have to, yeah, it's all good, friends. It's all good. I think she was just trying to see what someone else was asking. No problemo. Okay, so we have 1/6 and 2/9. Okay. Problem here is they do not have the same denominators. So we rewrite those as equivalent fractions with the same denominator. So you can do that a few different ways. You can write out all of the factors of 6, or all of the multiples of 6. So 6, 12, 18, 24, and then all the multiples of 9. 9, 18. Oh, 18 is the lowest common denominator factor. No. She's just very eager. Very eager. We were going a little too slow for her in 7th grade. She's just very eager. It's all good. Yup. And then we match them up. Denominator stays the same. Okay, so this is a good example to write down if this is something that confuses you. Yeah, that's okay. Everybody thinks different. It's all good. So we have our different denominators, right? 6 and 9. They don't match. We list the multiples. And remember, multiples are like you keep counting by that number. So multiples of 3 would be 3, 6, 9, etc. You're gonna have different denominators, but you actually change both. Jonah, that's a very good question. So we're changing the denominators so they match, but you're gonna multiply the top and the bottom. That's a great question. Because whatever you do to the bottom, you have to do to the top so the fraction stays the same. So it stays equivalent. Yep, 7/18 is the answer. Very good. Great question. Yeah, it should be a good refresher. You haven't done it for a while. So let's do that. Let's do this first one together, and then you guys can tackle the rest. So 4 and 6 are denominators, and they definitely do not match. So we got to list those. So Jonah says the least common multiple would be 12. Let's list that out. So we're going to go 4, 8, 12, 16. We'll stop there. Okay, those are our multiples of 4. Now let's do the multiples of 6. 6, 12. Oh, you're right. That is our common multiple. So that means we have to rewrite them so they both have 12 as a denominator. So 4 times what gives you 12? I'm not sure. Let's see what happens. 4 times 3 gives you 12. Yeah. So since we multiplied the bottom by 3, you also do the top by 3. So what's 2 times 3? 6. Perfect. Now let's do the other one. 6 times what number gives you 12? 2. Very good. And then 3 times what number? We got to do the same. We're going to also do 2. Yep. Yeah, so that'd be 6. Good. Yeah, you guys are right. So we're just going to add the numerators. The denominator stays the same, and you are right. 12 twelfths is the same as 1 whole. Good job. Very, very good. All right, what about number 8? What would I want both of those denominators to be? What's the least common multiple for 6 and 8? And remember, we do that by listing the factors. 6. Oh, someone just joined. Mariam. Hi, Mariam. Did it kick you? Holy number. That's right. It is. You're so right. 24. I think you're right there, Joy. I do. Yeah, so 6, 12. 6 times 3 is 18, right? No. Yes, that's right. 6 times 4 is 24. Okay. So then we'll list the common factors of 8. 8 times 2 is 16. 8 times 3 is 24. So 24 is the common multiple. Oh, no problem. No problem. Thank you for coming back. I knew you would, but thank you. All right, so we got to rewrite both of them with 24 in the denominator. And the denominator always tells you what you multiplied by, right? So 6 times what number gives you 24? 4. 6 times 4 is 24. So that means you do the same to the top. We're on number 8. Number 8. So 5 times 4 gives me 20. Good. What about the next one? 8 times what is 24? Ooh, Jonah says 9 24ths. You're right, Jonah, because 8 times 3 is 24. And then you do the same to the top. 3 times 3. We add those numerators. What do we get? Oh, I didn't even see. It's okay. That's why it helps to write this stuff down. It does. Yeah, good point here, Jonah. Good job. So we add those numerators. We get 29 over 24. Okay. And then we have to change it to a mixed number. Now, we really didn't cover doing much of that. Question, Parker? Just a lot of craziness. Okay, lots of chat math. Yes, exactly. So whenever you have an improper fraction like this, we have to ask ourselves, how many times does that denominator go into the numerator? Okay, so 24 times 1 is 24. 24 times 2 would be like 48. So that's way... No, it's okay. So that's way too big. So 24 goes into 29 one time, right? Because if we tried to do 2, 24 times 2 is too big. So it's got to be 24 times 1. And then 24 times 1 is 24. How much until you get to 29 then? What's the difference between 29 and 24? Because you always take the difference of how close. 5. There's 5 to go until you hit 29. So that becomes your numerator. There's 5 left over, and you keep the same denominator. And that stuff is on Moodle if you guys are having trouble with that. Oh gosh, and I just looked at what time it is. So here's what I think I will do. I'm going to stop here just because I think I put too much into the whole thing, but I want you to kind of process this stuff. Remember, subtraction is the same way. So like down here, 5 and 3, what would be a common, for number 11 here, what would be a common multiple for 5 and 3? 15, yeah. So you would get them both to be 15. So 5 times 3 is 15. So 3 times 3. And then 3 times 5 is 15. And then 1 times 5 is 5. And then you handle it the same way. 9 minus 5 gives you 4. So when you subtract, good job, guys. Very good. Seriously, good job. But what I'm going to do is I'm going to stop this here just because of time. And I do want to talk about multiplying fractions, but I'll make a video of that. and I will post that on Moodle. Okay? Just in case you guys need a little more stuff on there. So I will post this on Moodle right now. Right? Go math. Yay, I agree. But I will post a separate video about how to multiply and divide fractions on Moodle. I will do that today. I just need time to quickly film it. Okay? Does that work, guys?